Good afternoon. We're covering the demo for the full timing support for Class CD boundary clocks. Let's start by introducing ourselves. My name's Dave Watson and I represent EANTC. From Juniper, we have Bjornar Forthrun. From Microchip, we have Simon Butcher. From Ciena, we have
Kevin Estabrooks.
From Ribbon, we have Isaac Elbaz. And from Huawei, we have Lee Illen. And from Calnex, we have John from Calnex. So I'm going to present the short slide pitch, and then we will step through the test steps. What we're covering is the full timing support for Class C boundary clocks. And this is taking place at the Interoperability test for 2021 in Berlin. The purpose of the test is to verify that a chain of Class C or D boundary clocks connected on a network based on a full PTP timing support can maintain phase accuracy to the limits as defined in the ITU-T standards when subjected to GNSS service interruption. The goal of the test is to verify that a slave clock can maintain its synchronization quality when using the J275.1 telecom profile in a chain of Class C or D boundary clocks, adhering to the performance constraints as defined within the J2732 ITU-T standard. To do this, the topology that we're using involves two grandmasters and a chain of three boundary clocks with a telecom slave clock connected to them and using the Paragon Neo phase analyzer. The boundary clocks, the GMA boundary clock is provided by Microchip and it's the TP4100. The Grandmaster B is provided by Huawei and it's the ATN910D. Boundary clock 1, which is connected to the Microchip, is the Ribbon MPT 1100. Boundary clock 3 is the Juniper ACX 7100-48L. And boundary clock 2, which is connected to the Huawei, is a Nokia IXR-E. The telecom time slave clock is the Ciena 5164, and a 1 PPS output from that is connected to the Paragon Neo measurement instrument. The test steps, the test procedure to follow and what's the expected behavior involves the GMs to be locked to GNSS with the boundary clocks and slave clock disabled from PTP. The first stage is to enable PTP on the boundary clocks, and the expected outcome from that is that boundary clock 1 will lock to the GMA, boundary clock 3 will lock to boundary clock 1, and boundary clock 2 will lock to Grandmaster B. Once that lock's attained, we enable PTP on the slave clock and check that the slave clock will lock to boundary clock 3 as its source of PTP. Once it is locked, we will perform a 1000 second capture and measure the time error output against the Class CD limits as defined within the standard. We then will disable the GNSS to Grandmaster A, thereby causing a reacquiring for the network, where we will check that boundary clock 1 will then acquire its lock from boundary clock 3. Boundary clock 3 in turn will acquire its lock from boundary clock 2. Whilst this is happening, once they are locked, we will capture for 100 seconds to measure the telecom time slave clock transient. And then when it's acquired lock to boundary clock 3, we will perform another capture for 1000 seconds, again, measuring the time error against the limits as defined within the standard. At that point, we will re-enable GNSS to Grandmaster A, and we will check that boundary clock will reacquire its lock to that Grandmaster, and that boundary clock 3 will then reacquire its lock to boundary clock 1. Again, once those have acquired lock, we will capture on the telecom time slave clock to measure the transient for a short period. And then once lock has been attained, we will perform a final capture for 1000 seconds and measure the time error performance. We will now move on to the test itself. Can I ask the boundary clocks to enable PTP, please?
So the boundary clock 3 is now syncly locked to boundary clock 1, the ribbon, and is in acquiring mode in PTP. to lock on PTP, but that will take a little bit longer time.
NPT from Milburn is locked both PTP and SYNC. So this is SYNC. You can see the quality level. And PTP, this is the master. It's recognized as clock class 6. And you can see that state is locked.
From boundary clock 3 now, the Juniper. I can share my screen, Dave, because
Please.
I'm now both locked on SYNC and PTP. Here you can see the EP003, which is going to the boundary clock 1. The ribbon is locked here with a quality level of PRC. We are phased aligned. When we look on the clock level, we receive GMC class of 6 and receive it down to the slave. And here we also see the node is running in what we call the hybrid mode, both frequency locked and phase locked.
Okay, thank you. Mathis, what's the status?
I'm locked to the Huawei node. I'm letting share my screen for you.
Okay, thank you.
So here you can see that I'm locked on my port 1132, which is connected to the Huawei. Yes, and we're locked.
Okay, thank you. Kevin, can you enable PTP on your telecom time slave clock, please?
Yes, I'll do that now. So I'm currently acquiring lock, and I'll share my screen when I'm locked.
Okay, thank you.
Okay, so I've been locked for about 21 seconds now. So let me share my screen and I can show you what that looks like. So you can see what I'm showing you here at the top. I'm showing you that we are locked to SYNC. And if I scroll down the screen a little bit, you can see that we are also locked to PTP as well.
Okay, thank you. John, can you share your screen?
There we go. It's, the time error for start anyway.
Okay, thank you. So this capture will last for 1,000 seconds.
Thousand-second capture is finishing there.
So if you could stop the capture and apply, well, we've got the limits applied for the time error.
Yep.
Can we look at the MTI and apply the G823 sec mask? G823 sec wander limit. Yeah, that one will do.
Goes on. Yeah.
Yep. So you can see that it's passed, okay? So can I ask you to save those results, please, and save the report?
Yep, can do.
Meanwhile, Simon, can I ask you to disable the GNSS to Grandmaster A, please?
Sure. Okay, that's done. It's going to take a minute to advertise it.
Once it starts advertising it, can you show me the fact that it's doing it?
Sure.
Yeah, so I've got the degraded signal from GMA. You can see SYNC E is down to SSUA. And if you take a look at the PTP, you can see the Grandmaster clock class is 135. Yeah, so
Okay.
now it started unlock. It will stay on trace because we are generating the same clock class. So
Okay.
it's basically unlocked now.
Okay, thank you.
If we take a look at the boundary clock tree, I can share my screen. If we look up here now, we were locked on the, we receive SSU from Ribbon and from the Microchip there, since it turned off the GNSS. And we are locked on the Synky side towards boundary clock 1, the Nokia. And we are in acquiring mode here right now.
Mathis, can you show your status as well, please?
Sure. Everything's fine on my side, still locked onto the Huawei one.
Okay.
I can show the new status of the boundary clock tree now.
Simon, can you just confirm that you're now in holdover?
Here's where we were locked at start of the test, disabled it, and then this is UTC about 10 minutes ago, then we're advertising in holdover here.
Okay, excellent. Thank you.
So if we just go and take it from the top, we are locked on the Synky. We got PRC quality from Nokia, the boundary clock. We are phase locked here. Let me see. On both the Synky and PTP. And we are receiving a John class of 6 and sending it out. And,
okay, thank you.
So,
Isaac, what's your status?
I'm still receiving a clock class 135 SSUA from the GMA.
Right, Kevin, what's your status?
Currently, I first went into holdover, but then I acquired lock again to the Juniper. So you can see on my screen here, I am currently locked to Synky. And if you look down a little bit further, I'm also locked to PTP again. And you can see that I have a different Grandmaster identity now.
Excellent, thank you. John, can you start another capture, please?
Okay. Capture has just started.
Okay, thank you. So I think because we were looking at logs, we missed the transition. So we'll do a capture for 1,000 seconds. Okay, John, that's 1,000 seconds. Can I ask you to stop the capture? Simon, can I ask you to re-enable GNSS to the Grandmaster, please?
Sure.
Do you want to see the mask again, or?
Yes, please.
There we go. So
again, it passes both the time error limits and the MTI wonder mask.
Yep.
Okay, so if you could save that and generate a report, thank you.
Yeah, sure, I'll do that.
And Simon, if you could let us know when you've acquired lock again.
Will do.
And show the evidence of it.
Okay, so it's showing we're locked now.
Isaac, Mathis, and Bjorna, if you could check the state.
I still see SSU coming from boundary clock 1 ribbon. So I'm not receiving. Now I am suddenly seeing ESM quality PRC from ribbon. So we got a change in the ESMC quality level.
Yeah, I can see that as well. Let me just share my screen. You can see that Sync is locked and I'm receiving a PRC level, and PTP receives clock class 6, and you can see that it's locked on the microchip.
Excellent, thank you.
Right now I'm in acquiring mode. I'm locked on Sync, but I'm still in acquiring towards ribbon. So it may take a little bit longer time. I will let you know when I'm phase locked.
You do a short capture, John, please.
So the status is changed now, so I can share my screen if you would like to see this. So now I'm phase locked. So if you look there first on the Sync side, here again locked on the tree PRC, and we are phased aligned here.
Kevin, what's your status?
My status now is I'm acquiring lock again. Let me check to see where we're at.
John, when the capture reaches 100 seconds, can you stop the capture, please?
Yep, sure. 70 seconds into it.
Okay, thank you.
So if you look at my screen now, I'm frequency locked. And if I scroll down a little bit further, we are also phase locked as well. Let me show here the fact that we're now tracing back to the Symmetricom Grandmaster. So we're tracing back to the other Grandmaster now.
John, do you want to show the capture, please?
Yep.
Sorry about that. I just wanted to get, this is the screen I should have showed you before the 0D8. That's traced the other Grandmaster. I'll stop sharing now.
That's great. Thank you, Kevin.
Here, just over 100 seconds.
Okay, and can you look at the G813 transient, I think it is.
This one, I believe it is.
Yeah. So that's fine. That's great. So if you could save that file, generate a report, please.
You see the Grandmaster ID on the boundary clock tree, just to prove that we are sending that down and we are receiving it from
Yes,
DMA.
please.
So if you're seeing here now, this is the Grandmaster ID. This is the Microchip Grandmaster. This is my clock identity, as you as well will see here, and this is the ribbon here. So this is proving the same ID that Kevin just showed for the Grandmaster.
Excellent.
ID.
Thank you. When you've saved the report, John, can I ask you to start another long capture, please?
Okay, John, stop the capture, please.
So it's passing the limits, and this one again. And we'll go back to this mask.
Thank you. You can see yet again the output of the slave clock matches both the mask and the limits, thereby showing that across network change, the system is resilient and can cope with loss of GNSS to grandmaster and recovery from that situation without impacting the performance of a C or D 5G network limits. That's the end of the demonstration. Thank you for your attention.